Hi, and welcome to this video about simple shared memory between processes. So normally every process has its own address space, and these address spaces don't mix. And that's a good thing because one process cannot affect another process just by accident. However, in some cases it is useful to share memory between processes so they can cooperate with some data. There are basically two ways of doing that. The first one, which is the main mechanism, is using memory mapped files, also known as section objects. This mechanism is something I'll look at in a separate video. However, there's a simpler mechanism that could be used if you're sharing a few variables that are part of some DLL or executable. For an executable, it means all processes using that executable can share these variables, and for a DLL it means that all processes loading that DLL will be able to share these variables. So I want to focus on this option in this short video. So let's start by going to Visual Studio and creating a new project. So let's get a console application going here. Let's call that simple sharing or something like this. And let's try the basics. So if I go ahead and remove all this junk code here, I'm going to create a global variable called x. And if I go ahead and do something like an infinite loop, something like while true, and what I'll do here, I'll display the value of x, and I'm going to do a little sleep here for 1 second and increment x. I'm going to do that indefinitely, essentially. Let's add include for stdio and for Windows. If I go ahead and run this thing just by pressing Ctrl F5, this is what we'll get. We can see the numbers grow as we expect, each time incremented by 1. Not very surprising here. If I go ahead and go back to Visual Studio and press Ctrl F5 again to run another instance, we'll notice that the numbers start from scratch. They start from 0 once again. And that's because that x is a global variable, but only on a per process basis. I have two processes here. I can have, of course, more. They're based on the same executable, but these are still separate processes. And that's why we continue to get different values, and this x variable is not really shared between these processes. So can we make it shared? And we can. So the way to do that is to create a new section in the PE, and this can be done in Visual Studio using a pragma called dataseg. We can give it some name, could be any name, as long as the name is less than or equal to 8 characters, which is the limit for section names. And then we can declare the variables we would like to share. The important part here is to initialize them. Otherwise, they go to a different section for uninitialized variables. And then we can go ahead and just end this data segment, which means we essentially ending the section. So once we do that, this is all we actually have to do. Now this x is going to be in fact global on a system-wide basis, in the sense that every process using this executable will see the same one. So let's see if that actually works. So here's the first process, and it grows, x grows by 1, which is what we expect, but then let's add another process here. So here goes. And now you might see that things, well, still not changing really. And the reason is that this is just a normal section. We have to tell the linker that we'd like this section to be data that is not shared using copy on write, but really shared. So every process doesn't get its own copy. So we have to add a comment here for the linker. Of course, we can do that using the project properties, but I like to do that in code. I think it's just easier to see. And the section we're talking about here is called .shared. And we need to provide the attributes for that section, which is going to be readable, writable, and shared. So that little s, in fact, is the thing that's going to change everything and make x truly global. So let's test it. Here's our first instance. Let's grab another one. And now you can see that we have these values jumping by 2, incrementing by 2, and not by 1 anymore, because each process is actually incrementing the same exact variable. Of course, in a real life scenario, you might need to do some synchronization here, such as using a mutex, but for this simple example, this will do. If I add yet another instance just for fun, then now we have this variable starting with some value and incrementing every time by 3, because really it's being incremented 3 times every second. And so this X variable is now truly shared. And if you open that executable in, say, some P viewer, you'll be able to see this section. A new section has been created there, and it's going to have the shared attributes. Let me actually do that. Here's my own total PE. Let's find this executable and open it up. So we have simple sharing here. Here it goes, x64, debug, executable. And so we can see the sections here. There's a new section here called shared, which of course doesn't contain that much here because it's just zeros. But if we go to the properties of this section, you can see that we have here the property of shared. That attribute is the one that makes this behave as shared rather than just simple data, which each process will get a copy of if they make changes to the data.